Now you see we are talking about some more example of trigger. Just now I have talked about a thin target experiment. Okay, where we talked about a reaction like this, two body reaction, small a plus capital A, or small b plus capital B, and we were using one detector to detect B and another detector to detect capital B, and the target was thin. This A was thin, so after the reaction they can easily go out of the target and flow along, and we use detector X and detector Y to detect them. This was what was happening in a thin target experiment. But now let me use a thick target experiment. Thick target. So this is a thick target experiment. Well, A is very thick. So this means after the reaction of A plus A forming this compound nucleus, B star, the B star will be deposited in this A itself after the formation. And what will happen to the possible 5 channels? Suppose these are the 5 output channels. There can be many more. For the time being, just think about 5 channels. These 5 possible exit channels. So what will happen to them if we have a thick target? If we have a thick target, then all of them will be deposited in the target. Then if I put a charged particle detector, say over here, and I am putting gamma ray over here, these are the gamma ray, and this is a neutron detector, say neutron detector 1, neutron detector 2, charged particle 1, charged particle 2. Now tell me, if this is a thick target experiment, where will I get the counts? Remember, no, not just gamma ray. The neutrons will also be detected. Neutrons will not be stopped easily. So, and charged particles, they will all be deposited in this thick target. So, we will not be getting any signal in the charged particles detector. So, we don't use it. Forget about it. So, we will just do this experiment here using the neutron detectors and the gamma ray detectors. Okay. So, suppose what will be the coincidence? What are the various possible triggers? Oh, this time, suppose I have the beam defining counter S1, S2. So, trigger will be S1 dot S2. Again, next, what will be the trigger? Suppose I am interested in one event where we want to detect something which is in coincident with a neutron detector. So, here any neutron detector, any N detector, and here any gamma detector. This is one possible trigger where I am detecting only one gamma ray. Now there is yet another possibility. That is, when I am detecting, say, gamma ray in one detector and again coincident gamma ray in other detector. So suppose I am detecting some gamma ray in detector, say Xi, then, and there is something which is not in Xi, then detect. This is also a possibility. So this means I am having basically triple coincidence. So one neutron entering this counter, another gamma ray entering this detector, and there will be some other coincidence gamma ray which will be entering this gamma detector. So triple coincidence event. Such type of, so this trigger is basically made for such triple coincident event. Now this is the situation for thick target experiments. Okay. So suppose now let me again talk about thin target experiment. Let me rub this. So suppose again coming back to the thin target experiment. So this is A, this is thin target. Fine. So what will happen? Again, since the target is thin, so this time after formation, the B star can even fly and it will decay while in flight. The B star can decay in flight and during the flight all these 5 possibilities can be formed. Now there is something very dangerous. You should know. What is Doppler broadening? Why does it happen? Right, relative motion. Now what was happening in the thick target? In the thick target, this x1, say for example x1 was formed after the decay of B star to x1. The gamma rays which were emitted from x1, okay, you are detecting, say in some detector, some gamma detector, will you see any Doppler broadening of this gamma? No. You will not observe any Doppler broadening of this gamma. Why? Because the nucleus which was emitting this gamma ray, x1, it was at rest. So I am assuming that after formation, coming to rest in the target, thick target, then gamma was formed. Then you will not observe any Doppler broadening in the thick target experiment. But what will happen over here in the thin target? Here the compound nucleus itself can fly and then decay, and then x1 will be formed, and so when x1 decays during flight, the gamma rays that it will emit, they will be all Doppler broadened. So keep this in mind. So this is the peril of thin target experiment compared to your thick target experiment. Now again, if this in the thick target, it can also happen, Doppler broadening. How? Suppose the B star is formed, it is still not at rest inside the thick target. Even while it is moving on, colliding with other ions of the target, it decays, x1 is formed, x1's energy is very high, it is still not at rest, it is still colliding and colliding with other ions, atoms of the target, and even during its motion, it emits gamma rays. Then again, in the thick target experiment, you will again see that gamma rays exiting from the x1 nucleus will be Doppler broadened. So this is something I have not talked about. Remember, this is an additional issue. The gamma rays that we see, they will become thick, they will be shifted and all that, because of the effect of Doppler broadening. So this is yet another important issue that we see in real life experiments. Okay, so again, suppose I am using this time charge particle detector. Now I have to use the charge particle detector very close inside your target chamber. Okay, the charge particle detectors will be kept inside the target chamber, and the neutron detector, they can be kept outside. Why? Because neutrons can easily penetrate your target chamber and they can be easily detected outside. And gamma rays, they can also be put outside your target chamber. So again we can have a trigger like S1 dot S2 dot say charge particle 1 dot again neutron. So suppose I want to detect this event. So charge particle detector, any charge particle detector, any charge particle detector, any neutron detector, and dot any gamma detector. So see S1, S2, any charge particle, any neutron, any gamma. So this is when I am interested in only one gamma being detected in one detector. Suppose I am interested in coincidence gamma, then I have to put any other gamma detector. So this is yet another trigger which is possible. Here I am not talking about the beam down. Okay, I am just not talking. You can also use it dot Z bar. That is, don't take anything from the beam down. Something like that. So these are some of the very simple possibilities that we can have with thin target, thick target triggers. Okay. So there are so many possibilities.
Sir, in the real life experiments involving the compound nucleus, which target do we usually use, thick or thin?
It depends on the situation, what we want to study. Okay, each scenario depends entirely. The target, not just the target, the beam. whether it's a stable beam or a radioactive beam, everything depends. What energy of the projectile we have. Okay, even we can have inverse reactions where the projectile is more mass compared to target and all that. There are so many possibilities.